Okay, thanks for asking me out today. This is a topic that's really important to me. And what I'll tell you about is how I got into remodeling my laboratory to use several open practices, and why I think, so we hear constantly that this is something that we should do for science because it's better. We should do it for society so that they can see what we're doing and understand research better. But actually it's a giant burden for us. And while I'm not going to say that that's not the case, I'm sure that there's some research for which it's a bigger burden than others and some groups for which a bigger burden than others. What I will argue is that from my point of view, the burden of undertaking reworking laboratory workflow to introduce these open practices, I think has really personally paid off. And I'll explain what's in it for me, what I've found useful about this process. So, adopting open research practices. You're here today because you would like to do this and you think it's important to do it and you want to encourage others to do it. And broadly, scientists endorse openness, but they stop short always of prioritizing it, of saying this is, above all things, I'm going to make sure that I share data now. I'm going to make sure that I'm working in a reproducible way because it's perceived to be a lot of work. Oftentimes the work that we're doing follows on from some other work, and there's things that we can reuse, pipelines that we can reuse, data sets and procedures that we can reuse that's already not ideal and not reproducible, but we don't have to do any fresh work in order to just adopt them and do it again. The rewards, though, are then fuzzy. Like, do we switch to these open ways of working? If I did that, would it be only for the sake of idealism? Or, maybe it's easy to say that maybe that's important eventually, but right now I'm too busy to do it, and so I'll put it off until sometime in the future. So there's a bunch of strategic concerns that I think unfortunately stop people from adopting open research practices, and I hope these aren't of major concern. One is that it's going to slow me down. If I decide to change my analysis pipeline to a more reproducible script, then it's going to take longer for me to finish an analysis. That's one thing that people are concerned about. Another, one that I'm less sympathetic towards, is to think that why is it that someone else should benefit from my work? If I go to the trouble of creating a reproducible analysis pipeline, of figuring out how to share data and give it to other people, maybe someone else will benefit from this and get their own work done faster, or even republish my own data, and I won't get anything out of it. Why should I share it with someone else? What use is that to me? And finally, something I hear frequently, especially from students and early career researchers, is what if I make a mistake? What if I work out in the open like this and someone sees that I've made an error? What will happen to my career? Will I be able to work anymore? Will anyone want to hire me? Will anyone believe a word that I say? So I would submit to you that all of these concerns, while some of them might be important things to think about, above all, science is a collaborative effort. And you're never working alone on a project, even if you are working on a PhD project that you think is the defining start of your career, or something that you see as uniquely yours. I would bet a lot that it's not really that way, that your project is actually, whether you see it or not, embedded within some larger aim, and that there are other people who depend on the work that you're doing, just like there's work that was done before you started your project that you depend on. And your ability to do well depends on your access to that work. Other people's ability to do well depends on their access to your work. And you're working together to achieve something bigger. And so it's important from outside your lab and within your own lab that the people that you're collaborating with can transparently see what you've done and how you've done it. So I've been leading a laboratory for about 10 years, and it's taken me a long time to work out how important these kinds of reproducible and transparent workflows are to me. But I want to show you a few examples that I think bring home how much of the work that I want to do depends on work that my students have done, and depends on me being able to understand what they've done, not just in the moment that they're doing it, at the time I have to mark it, but many years later. So I'm a low budget, not really early career researcher anymore, but I certainly was when I started out. I did not have a grant. I worked at the University of Groningen in the Netherlands. We had shared lab resources, not much startup, not any startup, in fact. And I depended on being able to recruit master's students and volunteer undergraduate students in order to get work done. And it was possible, I found, to write nice papers and accumulate nice data sets by having chains of master's students do subsequent experiments that would all end up being part of a larger project. But this presented a lot of challenges. So when Madeleine van der Weyden worked on her MSc project, in which she graduated in 2010, I wanted to follow this up later. But when she turns this in June of 2010 or whatever, and then I have to teach for some months after that, I might not get back to her data and figuring out how to pitch the next experiment to another master's student for some months. I then look at those data, try to figure out what she's done, look at the analyses that she did for her report, try to see if I can reproduce them. And in the intervening months, there's bound to be information loss. There will be subjects in the folder on our computer that add up to a different number than perhaps were reported in her thesis, and maybe I won't be able to figure out why. There will be analyses that I try that come out a little bit different, and I'm not entirely sure why. This would happen over and over again, where maybe I can work out exactly what my student did, and finally I can figure out everything that I need to know in order to use that data set. Sometimes this would take me a lot more time than it would have taken to go ahead and start introducing some procedures to ensure that my students have done this curation ahead of time so that I have it for myself when I come back to their data 3 months, 6 months, a year later. So, similarly, I just have a few examples of this. The moment the data are collected and preliminarily evaluated can be years until they're actually in publication, and I might have to do multiple different versions of an analysis to figure out what I think the data mean or to satisfy peer reviewers on these data. It's not even only the people who are the authors of the paper that are involved. So I might have pilot data that's been collected by volunteer research assistants over the course of, ultimately in this paper, it took something like 4 or 5 years from start to finish. And at every point, I'm not working on it nonstop. I'm coming back to it over and over again. And so I need to be able to come back to it and quickly figure out in what state it's in. So this is all just to say that each of these students who were working with me thought they were working on something independently, but in fact, it would take something like 4 or 5 student projects all merged together to make a publishable paper. So I gradually learned over many years that I need in-lab transparency. I need to be able to ensure consistency in training researchers. I need to be able to keep track of what it is researchers need to know and what I have told this batch of researchers and what I haven't told them, what experiences they've had compared to what experiences researchers the year before or 2 years before have had. They sort of all jumble together in my mind. I need to make sure that everyone coming in has the same knowledge to start with, or at least has a way of getting it. I need to know the provenance of the data, sometimes years after it's been collected, and I need to protect the security of the data to make sure that it doesn't get lost. I need to stem information loss that comes with turnover. If you're working with students or short-term researchers, then sometimes you've got someone with you for a year or so, and then their expertise and skill is gone. You can't count on being able to get them back to find out what it was they had done. So when they leave, you want whatever they turn over to you to be entirely transparently produced. And then finally, to make it easy to publicly share when it's time, I'm absolutely for public sharing, but I think that it's easier to motivate people to do this when you think about, well, actually, you need this sort of transparency regardless of whether it's possible to make your data and your materials public or not. You need it in order to understand what's going on in your own group. So what I thought I would do today is explain 4 things that I have implemented gradually over time that I find extremely helpful and that help me manage what's going on in my own group of students and also help me feel very confident about posting my work publicly when it's time to do so. Those are my lab handbook, using the open science framework for distributing data and communicating with colleagues both inside and out the lab. Scripted analyses, which depending on what you do will either be entirely old hat or something that you think is a great burden to get into. And pre-registration. And for each of these, I'll describe a little bit of how I use them and why I thought it was worth it to adopt these particular things. So I'll leave the presentation for just a minute and show you. Oh, I thought I was connected to the internet. Do we not have EDU room here?
You have EDU room here.
Yeah, let's give it a moment and see what happens. It's usually quite seamless.
Yeah.
This does not require great internet power. All right. Okay. So this is my lab handbook. It's hosted on my GitHub page, and it's done in Bookdown, which is quite easy to use. Bookdown means that I've got a series of markdown articles that I've written and are marked down, and the Bookdown package joins them together into this handy framework. So what I can do then is just create a series of short pieces about various things that I want my students to know. Some of this is extremely mundane, like where the lab spaces are and whatnot. But for instance, more interestingly, how I want my students to work on OSF. I've started implementing this year with my undergraduate honors students because I want, when they leave, I want to teach them the skill of curating a data set. And so in addition to the normal sort of milestones that they have as part of their coursework, I have them set up an open science framework page. This is something they either have to do by being added to one that currently exists and having a subdirectory made for their component of the project, or they make an entirely new one if they're starting a project that's a new branch for me. And they're required to make a project, follows a template that I give them that has a directory structure that's common for most of the kinds of work that I would do, that includes a place where they can put the paperwork that they use to interact with any other researchers that are working with them or with the participants, that includes the run files that they will ultimately use to run their study, and that will eventually include a directory for their data and any communications that they give. The idea then here is that I would like to make it so that I can even not mark their thesis if they have not put data up here where I can see it. Now, this is not public. They're working in private on Open Science Framework, despite this screenshot that I have in here. But when the time comes, if their project is part of a larger project that ends up getting published, then having this done all while the data are being accumulated and the sub-projects are being finished, it makes it not such a burden for me to figure out if all of the data are where they need to be at the time that I want to make it public. So let's see what they do. I tell them about how I would like them to name things so that they don't do things like name everything dissertation, experiment, or something like that. I tell them about how and when we would keep things public or private versus public. I explain to them a bit about using the wikis and the order of events that they should go in, which mirrors the order of events that they would expect their project to go in. You're preparing and generating a plan, ultimately writing some kind of pre-registration document that at minimum just is basically the methods section for what they would write about their experiment, plus the paragraph before that motivates why you've manipulated things exactly that way, and the paragraph after that explains how the data are going to be processed. Similarly, things that I'm very likely to forget about year on year, like exactly what needs to happen when a new researcher joins the lab in terms of research ethics, what sort of things they have to, what sort of courses they have to take, and various web trainings they have to complete, and at what point they need to be made part of the research application, all gets codified in here, and I can update it as needed. Because it's on GitHub, and because each of these chapters is a discrete R markdown on GitHub, principal, the people who work with me who are also familiar with R markdown can, if they want to update something, if they see that something has changed or if there's a mistake, they can go and update it themselves. And then I can just approve the changes that they've made, which ultimately will be a lot less work. Let's see. This is online, but I'm happy to show more of it later if it's of interest. Okay, so why do this? This is something that has been my New Year's resolution for at least 7 years, writing a lab handbook. So it ends the theory of mind games that I have to play when I'm training a new student. It's difficult for me to keep track of what it is that someone just joining my lab knows and what they don't. And that would be one thing if it's just happening at one point in a year. Then I make some curriculum that new students coming in the autumn always get. But that's never the case. There's always someone in the middle of the year that comes around and would like to have some kind of lab experience, and it would be nice to be able to offer them that experience, but I've already done a discussion about ethics or something with my current students. I've already explained things that they need to know about experimental protocols, and so then I have to do all of this work all over again for the sake of having 6 hours a week or something of free assistance. I always take that assistance, but it might mean that RA doesn't get as good a training as they would otherwise get, and that might have some effect on the quality of work that I'm able to get out of them. It articulates a standard to aspire to, which I'm finding students are finding increasingly helpful. So students know what I would consider professional. In some cases that means worthy of the highest marks that they're able to get. In other cases that might mean what I would consider sufficient for projects to become part of a project I might consider publishing later. Now, why make it public? So lots of people have lab handbooks, I think, and they're not necessarily public. One is to get feedback. One of the annoying things about having a document like this is that you have to update it. And if other people can see it and other people can talk to you about how they do things and you can compare and contrast, then it's easier to get this feedback in real time and update more quickly when you can keep track of the changes you'd like to make. Having it on GitHub means that other people can even suggest changes and update it for me if they really want to. Another reason is to be helpful. I want for people to benefit from whatever work that I have done. And I'm happy to share something like this if it means that other people can use it to their own benefit. Going along with this, it's not entirely just to be helpful to other people. I also like to be able to influence standards of the broader research community that I'm a part of. There are some things that are very important to me about how data are collected and what we know about where they come from and so on and so forth. And it's in my interests if I can try to get people who are not part of my lab, who I work with, to try to adopt the same sort of standards that I think are the good standards. Also, something like this enriches the descriptions of the method that you publish. It's the methods that you write up, we try very hard to make these the definitive method of the experiment that we conducted, to say everything that someone would need to know if they were replicating a study. Has anyone tried to do a direct replication though? Like every time I've tried to do it, there have been detail, even no matter what, I can start off looking at a method and thinking that it's extremely clear and well specified. But once you start trying to go about making these materials and recreating them yourself, there is bound to be detail that could be really important that's not there. There's also background detail about how the lab works that could affect whether a replication is successful or not. And that sort of thing might come out of a lab handbook. So the other thing that I've been finding extremely useful now for a few years is the Open Science Framework. This is a free tool that you can use to organize. I think of it as a way to back up, actually, and eventually share finished components of your research. So I think at Cambridge this is probably going to be less important because I understand you all have a university repository that seems like it's really, really good. We don't have that where I'm working now, and despite asking for it for years and years, there's not much consensus about what it should look like yet. So I expect it will be years and years before we do have such a thing. So I ask my students and research assistants to share their finished products on Open Science Framework. At first, just privately among the people who are involved in that particular project. This isn't like a versioning sort of thing. So I do some versioning, but I have to say I'm not interested in micromanaging my students' projects that much or having anyone micromanage mine exactly that much. I'm not interested in seeing every single iteration of the experimental software. I want to see it when you think that it's in a state where it's pretty much ready to go, and then we'll discuss it. So we might put a series of maybe 2 versions of something on OSF. It's not like where we save things at the end of the day. It's where we put finished products. So software, stimuli, and protocols, we consider them finished when we've tested them and we believe that they're ready for participants to use. Pre-registrations, we try to do this now, and we would consider them ready at some point before data analysis begins, ideally before data collection begins. Anonymized data sets. We would consider this finished and ready to be on OSF when the data set is closed to new members. So it's not like we're updating it on a daily basis or anything like that. Analysis code and papers, they would be on OSF when they're ready from scrutiny for someone. So the standard that I usually use is that this stuff goes online when I'm about to share it with other colleagues, when it's in that much of a finished state, or when it's going out for peer review. And when it's going out for peer review, unless there's some reason why I can't do it, that's when the private to public switch gets flipped. So reasons that I really like OSF. One, it's free, which is very nice. I don't usually have lots of research money to work with, so this is important to me. And like I said, Cardiff does not have an institutional repository, so we don't have a central server for data anyway. You can control project members. So I can make it so that at the beginning of a project, a few of us only have access to this. I can expand access as needed to individual people as needed, or make it finally public as needed. You can get a DOI, a digital object identifier, assigned to your project. So this would be unique from whatever paper ultimately comes from the project, which can potentially be very useful if you've created software or if you have collected a data set that is generally useful beyond its use in your specific paper. So you can end up getting more citations for yourself in your project by sharing this information. And you can make sure that those are stable and count towards your record by getting these DOIs assigned, which is very easy to do in OSF. Pedagogically, I'm finding it to be a very good tool for supervision. So you can see quite quickly, more quickly, I think, than when some collection of my 5 or 6 undergraduate students are sending me things via email or trying to communicate with me in some other way, where the project stands. I can at a glance see, all right, these 3 students have got everything ready to start data collection. They've tested everything. They're ready to go. These don't quite have what they need yet. I can see who needs my attention or which projects need my attention. So how I've been using it. Students are introduced to OSF at the start of the project. I run an OSF tutorial for undergraduate students at the beginning of the fall semester. And then, so I've invited other students besides mine to do this. And then my students, once we start working with it, are either added to an existing project or I ask them to create their own based on a template. Then gradually throughout the semester, I just add a few more milestones into their workflow than other students and other labs are required to do, which involves uploading these materials when they're ready. And I ask them to register their project at important milestones. And I do this for a few reasons. One is that it creates, you can think of it as a backup. When you register a project on OSF, it's creating a frozen copy of that. Now, what you normally think of this as good for is having this timestamp that says, okay, on November 20th, 2018, this project had these run files associated with it. It had this pre-registration associated with it, but no data. And on March 15th, 2019, now there's an anonymized data set. And so you can use that as evidence to show that your pre-registration preceded data collection. But also, what it means is that you've got a backup of whatever those materials were when you registered on November 20th. So if you're in a situation where you've got people working on a project for a set amount of time, where they might not actually finish that project, and there's a moment in which they're going to be handing it over to someone else, then registration will mean that you've got a record of where the project stood, like for instance, at the moment of this handover, which is something that I foresee will be really important. Finally, the OSF page then supplements whatever we publish. It gives another source of information for data or for useful custom software and analysis scripts that other people might use and might also cite. I think the single most useful thing that I have changed about the way that I did research when I was trained to do research as a PhD student and how I do research now as a PI is that I only run scripted analyses. So this was not at all part of my training. The lab that I worked in as a PhD student primarily used Microsoft Excel to process data, and then we transferred it into a more powerful statistical program, Statistica, to do analyses that weren't easily afforded in Excel. What I learned over time is that the workflow that I learned in my training, although I found it easy to do by then, was not at all easy to reproduce. The first PhD student I worked with, we started out doing things like this. He collected his data, he converted it to wide format in Excel using pivot tables, and then transferred it into SPSS to do inferential analyses. And I found it very frustrating. First I found it exciting. He would come to me with results, and he would be really excited that he found some kind of interesting correlation or interesting effect. I'm like, oh, that's really great. I didn't really expect that. I'm going to try to reproduce it. So I would go through the same steps he did, don't find the same thing. There are instances where we never figured out what those initial results that he brought to me came from. We couldn't figure out if it was my mistake in reproducing or his mistake in initially doing it. It's definitely a mistake because we never found those particular results ever again. And there's no way with that kind of workflow to figure out where the problem could be. So there's so many instances where you can make a copy-paste error and these aren't tracked in any sort of way that you could ever find. So doing this workflow that I didn't perceive to personally cost me any time, it's actually costing me a lot of time. Every time I needed to check something or reproduce something, every time I came back to a data set that I hadn't seen for a few months because I was busy teaching or whatever, and I wasn't quite sure where I left off with it, and steps that I may or may not have taken, were not really recorded, and I would maybe spend a morning trying to infer what had been done, ultimately just to decide that I couldn't really be sure and I needed to start from scratch anyway. So scripted analyses became really important. At some point I decided that we weren't doing things this way anymore, and I would only be doing scripted analyses. The principles that I adopted were that processing data should never lead to information loss. And so the script for processing the data starts from the anonymized raw data file every time. Everything that's done to the data is recorded in the script. So that can make for, it seems like that would be quite a long list of things to be done, but in R, these things are done in a matter of seconds. So it doesn't really make any difference if you're starting your analysis every time from the raw data processing. It's still only going to take a few seconds to run from start to finish. Everything then is recorded in the script and documented, so it can be changed very efficiently. If I want to change the way based on something a reviewer suggests or something a colleague suggests, if I want to change the cutoffs I'm using to exclude reaction time data from my experiment, then it's a matter of just changing the one line of code that sets those parameters and running everything again, and everything will change. And I know it's consistent. So once you have a routine, it's much, much faster. Changes can be made quickly and easily, and you've got a record of every step you've performed. The analysis is then fairly reproducible, assuming that whoever wants to reproduce it has access to the same software that you have access to. And I use open source software. I use R and RStudio, various packages that are all publicly available. There can be some difficulty with making sure the same versions of them are always used, but largely much more reproducible than what we used to do, no doubt. And it means that my colleagues, both inside and outside the lab, can see exactly what was done. Now, my students don't all script, so we do not teach programming at all to our undergraduates at Cardiff at the moment. And I don't expect them to learn how to do this in a year. They end up getting a flavor for it because the one thing that I insist that we do together is the initial data processing. So what happens then is whoever was involved with collecting data brings their notebooks with any notes they took during data collection that might be used as evidence to exclude a participant, for instance, or to make some decision about what would be excluded and what would be included. They make sure all of the data have been uploaded to a place where we can access them. And together, we sit down and create this pre-processing script. We go through their notes, we compile the data. At this time, I say we, I'm the one typing, but they can see what we're doing and we comment everything. So we can have a list of all of the participants that we're going to leave out for whatever reason and a key that tells us why we're leaving them out. We make decisions about any other sort of outline decisions we need to make, whatever other decisions about how the data need to be processed that need to be made, so that then we all have access to this script. They can use the comments to write their methods, and then they can take the output process data and do what they like with it. But at least we know up to that point that we've got exactly the same thing. And it's recorded. So finally, another thing that I've adopted that I find very useful is pre-registration. And that is documenting detail of the method and analysis plan before analyzing or collecting data. Why I find this helpful, there are a few reasons that are not necessarily the normal ones. I mean, of course, I don't want to be p-hacking myself, and I don't want my students to be p-hacking. But importantly, I found it prevents rushing into data collection. I found myself frequently in a position where I was allowing students deadlines to determine whether a study was ready to start or whether it was ready to stop. We're going to start this study because we have to in order for the students to get it finished in time. Or we've got subjects this month and we're not going to have them next month, so we better get to collecting some data right now. Sometimes that was good. Sometimes that saved me time and got me data ahead of time when I wanted it. Other times it meant that I ended up collecting data that I didn't necessarily want. Once I sat down and got to looking at it or got to writing a methods section, I would think, oh, wait, I should have done it this way. Actually, I so much should have done it that way that I don't even want these data. I'm going to do it again later. It prevented rushing into data collection, which I think usually saved us time, even if it meant that we would start later. It ensured that the students collecting the data understand more about what they're doing. And this is really important because it means that they can provide useful criticism ahead of time. When we rush into things, what would happen is they would learn on the go, which of course they're going to learn on the go anyway. But the more they know when they start, the more they understand the design, the more they've thought about it, the more I can use their brain to help improve the design, the more they get out of it in the end as well. It makes it clear to students then how to proceed with data analysis. So I'm convinced that this time up front spent articulating how they're going to process the data and what they're going to do with it is saved later in the year. When they get the data in, they have some idea what's going to happen next. Whereas I've found that wasn't usually clear before I started asking them to pre-register. The data would be in and be like, well, so what now? They'd have some vague idea of sort of which category of analysis they were doing, but not much idea of how to get there. And so, yes, we all know that pre-registration, the main point of it is to prevent p-hacking. That's also really good, but honestly, that was the least of my concerns. I've found it useful for so many reasons. It probably slows projects down, pre-registration, but it also, as I said, prevents wasting time running suboptimal designs. It helps catch confounds before we've wasted subject hours on Paradigm, and it improves the pedagogy involved in having students run a research project in the first place. Importantly, too, it does something that I really like. It inculcates a lab culture where it's clear to the students that speaking up about design and their questions about design is welcome, not where they have to try to hide that they don't understand something. Because if they don't understand something, I mean, that's to be expected. You won't understand everything instantly. But it might be that if you don't understand something, then it actually could be made clearer or better somehow. And I would like for them to be able to help with that process. All right. So those are the 4 things that I have implemented. And why did I choose these things specifically? So I want to make clear that I didn't choose these things because they're the things that are in the Open Science Zealots Handbook and that we all have to do. Different projects are different labs are different. There are, I don't think that there are a set of things that everyone must adopt all the time. I adopted these because I saw they would solve specific problems that I experienced and that over time would save me time and effort rather in proportion to the cost that I was putting in up front. I didn't adopt them wholesale immediately. So I did not, when I started scripting, I did not decide I would not do any work until I could manage to do a full scripted analysis. There were things that I struggled with that I just didn't do right away. There were other things that I wanted to do that could only be done by scripting, and I concentrated on those. I probably did maybe 2 or 3 projects where I pre-processed data in one way and then moved to R for an analysis until I learned how to implement the whole pipeline I wanted to implement. So I don't think that there's, well, I mean, I think scripting is really great and I'm very happy to have done it, but if I needed to do it in a gradual way to do it at all, then that's better than never adopting it in the first place. The other thing that I think is important about these things is that thinking about openness in the lab, I think that's something that everyone could agree on. Nobody wants it to be a mystery what their researchers and students have done to get the data. Nobody wants researchers to leave having the data in their possession and not have shared it with you. Practicing openness in the lab and thinking about transparency among lab members and doing things to reproduce each other's analyses and to check the provenance of the data means that when you think it's time to make the data public outside the lab, you've gone through some checks that make you more confident that you're not going to embarrass yourself by putting your code and your data out there. There's less of a chance that you will have failed in something important because you've got multiple eyes in your lab looking about it. So when you're confident about the provenance of the data, the reproducibility of your analyses, and the quality of your design, it's just, you feel less anxiety about sharing these things with other people. You feel more excited and confident to share them with other people. And I've personally found sharing with other people to be beneficial. I think that there's evidence to show broadly, not for me personally, but it increases the number of citations that a paper associated with the data receives. I do think that it tends to increase, personally have found it increases one's reputation. That people assume, for better or for worse, they assume that your work is of higher quality when you're willing to share it than when you're trying to keep it private. And you get lots of goodwill from others who appreciate your resources, for whom you've saved time because you've shared programs and scripts and data that they can make use of. So I just want to say that I think the main reason for transparency, the main selfish one that I espouse, is that it's for my team. It's for the people that I'm working with so that we can do better work together and so that we can be more sure about the work that we're doing. And of course, it's also for science. This is an extract from the first edition of the Royal Society Journal that makes very clear that the whole purpose of communicating about science is to share information with other people for the sake of curiosity and knowledge alone. But even though I think it's important for science, I think it's mostly for you. I think it's mostly for you and your team to do better work and to feel better and more confident about the work that you're doing. Thanks very much for your attention.